we have to prove that limit as x tends to 4 of x minus 4 over square root of x minus 2 equals 4. So at first we're going to find left-hand limit. So it's going to be limit as x approaches 4 from the left side of x minus 4 over root of x minus 2. So now we substitute x by 4 minus h, as h tends to 0, minus 4, and over root of 4 minus h and minus 2. So that's gonna be limit as h approaches 0 of 4 minus just negative h. So we subtract 4 over root of 4 minus h and minus 2. And now we multiply our fraction by square root of 4 minus h plus 2 and divide by the same expression. So it's going to be limit as h approaches 0 of negative h times square root of 4 minus h plus 2. And in the denominator we're going to apply the difference of two squares formula. So we get square root of 4 minus h squared minus 2 squared. So that's going to be limit as h approaches 0 of negative h times root of 4 minus h and plus 2 over 4 minus h and minus 4. So we subtract 4 in the denominator and we get just negative h. So now we can cancel out negative h and to get limit as h approaches 0 of root of 4 minus h and plus 2. So we substitute h by 0 and we get square root of 4 plus 2, which equals 2 plus 2, and that's going to be 4. So that's the value of left-hand limit. And now we're going to find right-hand limit. So it's going to be limit as x approaches 4 from the right side, 4 plus of x minus 4 over square root of x minus 2. And then limit as h approaches 0, and we substitute x by 4 plus h, and that's going to be square root of 4 plus h and minus 2. So that's equals limit as h approaches 0 of h over square root of 4 plus h and minus 2. And then we multiply by square root of 4 plus h and plus 2 and divide by the same expression. Therefore we get limit as h approaches 0 of h times square root of 4 plus h and plus 2, and in the denominator we apply the difference of two squares formula. So it's going to be root of 4 plus h squared minus 2 squared. So that's going to be limit as h approaches 0 of h times root of 4 plus h and plus 2 over, here we get 4 plus h and minus 4. So now we get h times square root of 4 plus h and plus 2 and h in the denominator. So after we cancel out h, we get limit as h approaches 0 of square root of 4 plus h and plus 2, and then we substitute h by 0 and we get square root of 4 plus 0 and plus 2. So it's going to be 2 plus 2, and that's going to be 4. So therefore the limit exists as a left-hand limit equal to right-hand limit, and therefore we get that limit as x approaches 4 of x minus 4 over square root of x square root of x minus 2 equals limit, left hand limit, and equals right hand limit. Which equals 4. Hence, we proved our identity.